All right, we are in CC3, and this is section 3.1.4, number 334. So it asks us to use this rule, right? The rule is y equals 2x plus 1, and take that rule and complete this table. So part A is completing that table. So on your binder paper, because you're working from your textbook, you'll need to rewrite the table. You can write it horizontally or you can write it vertically. Either way, you've seen me take those tables and on the board put it vertically. Either way, or you can actually do it the way the textbook has it, which is a horizontal table. So your X is your input and your Y is your output. So, and this is our rule that we're using. So I'm going to put in those values, the -4 all the way down to all the way up, I should say, to +4. So from -3, so -4, -3, -2, -1, 0, 1, 2, 3, and 4. And so I've just got to find the corresponding Y value, the corresponding output for each of these inputs. So that looks like this. So we take for -4, plug in -4 into that number there. So into that X. So it's 2 times -4 is -8 plus 1 is -7. 2 times -3, right, is -6 plus 1, -5. And again, keep going. So -2 times 2. So 2 times -2 is -4 plus 1 is -3. And then putting a -1 in, 2 times -1 is -2 plus 1 is -1. Putting in 0, you're going to get +1. Putting in 1, you're going to get 3. Putting in 2, right? So we're just putting the value, continue to put that value in place of the X and do the math. 2 times 2 is 4 plus 1 is 5. 2 times 3 is 6 plus 1 is 7. And 2 times 4 is 8 plus 1 is 9. Now, when all said and done, hopefully you see a pattern of numbers, correct? So we see the pattern that the numbers are increasing by 2 every time. And that's what we should see if I have my inputs in consecutive order. My inputs here are by ones, right? And since I have my inputs by ones, I'm seeing my outputs go by twos. And that's because of that number in front of the variable, in front of the X. My rate of change is 2. All right. So we'll see that more as we get into graphing, etc. So now it tells me once I fill out my table, part B, it asks, so this was A. So part B, it asks, what are the greatest X and Y values in the table, right? So the greatest X and Y values are 4 and 9. Those are the greatest X and Y values. And it wants to know what are the smallest X and Y values. So the smallest is -4, -7. So those are my smallest X and Y and my largest X and Y. It wants us to use this information to scale our Y and X axes appropriately. I want to make sure I can get up to 9 on the Y axes and get all the way down to -7. So this is where I'm going to get graph paper now and plot my points on graph paper. So let me move it so we can see it all. There we go. So I know I have an axis here that I want to make sure I can get to all the way up to 9 and all the way down to -7. So I might use go by 10, go 10 on my top scale and about 8 down on my bottom scale, right? So and then on my Y, my X values, I just have to make sure I go from 4 to -4, 4 positive and -4. So I'm going to count in 1, 2, 3, 4 in this direction. And so I can make this my Y-axis. Actually, I'll go one more over. So this is going to be my Y-axis, and I need a nice and straight. Just to make sure I have enough, I'll count down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right there will be my 0. my 0, 0, my origin. And I should have enough space now to graph based on the numbers that I'm inputting. So I'm going to go and I'm going to scale this. It wants me to label my axes. So this is -1, -2, -3, -4, and then +1. This is my x-axis, correct? 2, 3, 4. And then if I'm going on my y's, my y, I know I'm going to go by 1, so I'm just going to make it not look so cluttered. I'm going to go up 2, then skip, go up 4, then skip to 6, and then 8, and this would be 10 way up here, right? And I know my axes keep going, so I tend to also like to put arrows on my axes. So that way it shows that the axes do keep going. And then going down, this would be -2, -4, -6, -8. And I only need to go down to -7 on my y. So I think I've got my labels good. So now I'm going to graph this. So if we're graphing our values here, where is -4, -7? -4, -7 would be right here, right? So that's -4 on the x, right? That's this point here, -4, -7, right down here. And then -3 and -5, so -3 on the x, -5 on the y, right? -2 on the x, -3 on the y, -1 on the x, and -1 on the y, so right there. Hopefully we start to see that pattern already. And then the next point is 0, 1, so 0 on the x, and so 0 on the x is here, and then 1 on the y is right up here. So that's 0, 1, and then 1 on the x, 3 on the y, 2 on the x, 5 on the y, and 3 on the x, and 7 on the y, and 4 on the x, 9 on the y. So there are my points that I got, the input output values from that rule, from the rule y equals 2x. So you can see it, y equals 2x plus 1. So once I have my graph, once I have my points plotted, it wants me to connect the dots. So I use a straight edge. Make sure you're using a straight edge to connect the dots. And I will connect them. Remember, because why do we connect them? Because this line, this solid line, represents all the values that can make that equation true, right? The solid line show all the solutions to that equation, right? So that's why I have to graph a solid line, because there are values in between these whole number points that actually exist within that equation, right? I could put in my table, I could ask you what 4.5 is. What is the value at 4.5? And there would be an answer. I could plug in all the different fractional decimal values and still get outputs. So that's why I use the line to show all of those possible points. And then I also put arrows on either end of my line, because that shows that there's a continuous pattern and the values continue going in both those directions. All right, there we go. That completes 3-34.